It's a yeah, different.
And we discussed about the equation of SHM, how to find time period by force method. Now you can try this question. Start with this question. Tell me, are you getting it? Okay. You have any doubt, you can ask, or you can explain the process what you are doing. So if the particle is doing circular motion, then what will be the motion of its shadow will look like on the wall?
Banana.
Yes. So now just apply the concepts of SHM to the shadow. What is the problem? What happened? Are you doing, not doing?
Yes, sir.
Yes.
Right. सर सर इसके calculus नहीं है omega square के साथ सर
Maximum
maximum acceleration is r omega
maximum acceleration is, you are saying, r omega.
r omega square
R omega square. That is correct. R omega square, when you are saying, then what is omega here?
तो फाइव में
Sorry.
सर omega is equals to minus m e whole square right
Omega is
Sir, F square minus
Speak little louder. Your voice is not audible. Speak louder.
Sir, now I'm audible, sir.
Yes.
Sir, omega is F square minus mg whole square by mr square whole power 1 by 4. Sir.
Okay. Okay, now next part, B part.
So type it will be 2 pi into mr square by f square minus mg whole square. 2 pi by omega no, sir, time period.
Yes. Yeah. How you calculated omega in the first case? How you calculated omega in
Sir,
the first?
yes, sir. Sir, by using the equations of motion only, sir.
Yeah, tell me the equations.
Sir, f square equals to mg whole square plus m omega square r whole square, sir.
From where this equation came, f square plus this. From where this equation came? Before this equation, the most fundamental first equation. Tell me.
So first of all, I will written the simple harmonic motion equation, sir.
Tell me the equation directly.
So the simple harmonic motion we get is y equals to
Y equal to.
a sin omega t I assume, sir.
Okay.
Then from that I got acceleration, so minus a omega square sin omega t.
Okay. Omega square. Okay. Okay. Then
But then I applied the free body, sir. Free body diagram and squared on both sides, sir.
okay. Then
So then from that I got omega, sir.
how? How?
Sir, free body equation will be f equals to mg plus m r omega square, no, sir.
Tell me the equations. F equal to
F equals to mg plus
mg plus
m omega r, no, sir.
m omega.
Sir,
Go on. M
omega r,
omega.
sir. R.
M omega r.
M omega r square, sir.
M omega r square. Or m omega square r.
M omega square r, sir. The free body diagram.
How this term came m omega r square?
So we can say this is the force acting toward the center, no, sir. M omega square r. And the F is the force
That is
acting
centrifugal. You are saying
centrifugal. It's a centrifugal force.
centrifugal is m omega square r.
Yes, sir. And m omega square r plus mg equals to f, no, sir.
You are saying m omega r square.
That's m omega square.
Okay. So this is the equation that you are getting, right? Is this the equation that you are getting? Look at the screen.
Yes, sir.
F equal to. Now this is wrong. How you got this equation? From where? How this equation? Explain.
So for the body,
How?
for the ball, mg will act vertical downward motion.
Yes.
Sir, and the force, the tension will act F towards force along string motion.
Yeah. F will act in
Sir,
this direction.
yes, sir. And centripetal force m omega square will be r will act also towards the central axis.
Okay. Then how you wrote this equation?
Sir, so then we can write from the it's triangle equations, right? They saying it's a right angle triangle also. Applying the Pythagoras theorem, I am writing, sir. I'm saying.
Where is Pythagoras theorem in your equation? You are saying F equal to mg and m omega r square.
Sir, F is in this upward direction also. And mg vertically downward and this m omega square are these three vectors are forming an right angle triangle also. That's why I'm using an
You are
Pythagoras
saying
theorem
F
also.
mg and m omega square r as forming right angle triangle.
Yes, sir, are forming a right angle triangle.
Even if suppose they are following right angle triangle, then also how can you write this F equal to mg plus this? This is vector
Sir,
addition or simple magnitude addition you are
sir,
saying.
sir, I'm saying F square, sir, all square terms, sir.
But you never said that in this last 10 minutes. You never said F square. You said
So
F
from
equal
first
to.
one, I'm saying F whole square, sir, everything.
So that you never said. Again and again repeat. I have written also. At that time also you can say, sir, write F square. You are not saying. Okay, now you are saying F square. Now,
F
then
square is
also it is
mg whole
wrong.
square. Sir,
Then also it
mg
is
whole
wrong.
square. It will be mg square plus m omega r
Now
square
for
whole
the
square.
first time you are saying mg square. Till now you are saying mg only. Now you are saying mg square for the first time. Then
Sir, and m omega r square whole square.
now whole square. Now for the first time you are saying this whole square. Okay. So after this, what you did?
Sir, from this, we need for an omega now, sir. It will be f square minus mg whole square equals to m omega r square now, sir, whole square.
Hmm.
Then we get m omega square r equals to square root of f square minus mg whole square now, sir.
Hmm.
And we
Okay.
get omega, then we can get time period 2 by the omega.
Okay. So when I ask something, be very careful what you are saying. You always say incomplete and wrong things. Always. When I am writing, you can say, no, sir, what you have written is not I am saying. I have written F equal to mg omega square r. Why you are not saying that it is F square? And even if this is F square, then also it is wrong. You have to say this
Whole
square.
f
You have to say
square.
this. Okay, go for next part B.
So that similar time period will be 2 by the omega only.
Yeah. Okay, that is correct. Okay, now you can go for this part. So you can try this and you can ask your doubt. You just have to tell me the equations that you will write. Just do it fast. After that, we'll cover few more theories there. This chapter. Theory part will cover.
Sir,
Yes.
sir, first we will draw favored atoms after giving a lateral displacement.
Again, your voice is very low. Speak louder.
I know 1 minute. Sir, now I am audible, sir. Clear.
Yes. Always speak like this. Hmm. Tell me.
Sir, sir, after giving a lateral displacement, sir, if
After,
you
speak
assume,
louder. Louder.
Sir, after giving a lateral displacement, sir, ask for the question.
Okay. Okay.
If you assume that the ball is making an angle theta, sir,
Okay.
with respect to horizontal, then a component of tension in along vertical directions will be T sin theta, no, sir.
It will be cancelled, no? T sin
Yes,
theta,
sir.
T sin
Yes,
theta.
sir.
Yeah.
Yes, and the force will be 2 sin theta, no, sir.
And
So this student will
go
be
on.
2 to sin theta,
Yeah.
no, sir. Yes, sir.
2t sin
So
theta,
from the figure,
yes.
if you from the figure, 2t in place of cos theta, if substitute x by L, no, sir. If x is the lateral displacement, L is the length of the string.
Okay.
We get acceleration equals to minus 2t x by ml, no, sir.
Okay. Means,
Sir, means we can say d square x by dt square is minus 2t x by ml. From equation of motion, we can get acceleration as d square x by dt square, no, sir.
okay.
Sir, and we can say that displace equation of simple motion if we assume a sin omega t, sir.
Again, can you again repeat?
Sir, if you assume that this equation of simple harmonic motion, sir, x
Which
equals to
equation? Which equation?
so simple harmonic motion, sir. He's
No, which
asking,
equation you are saying is I will assume as simple harmonic motion.
sir, this d square x d square x by dt square, sir.
And d square x by dt square equal to what?
So this is equals to minus 2t x by ml, sir, we get.
2tx. So this you will not assume it is.
It is, sir. I'm saying, yes, sir. Sir,
Okay.
after that, I'm generally saying, sir, if we assume that the
Okay.
displacement
Yes.
harmonic equation
Then
is,
x will be a sine omega t. Yes.
yes, sir.
So
From that, finding d square x by dt square, sir, and equating, we get the value of omega and time period we can get now. So that is I'm saying, sir.
why not omega? You can get directly from here. This is omega. Omega square x.
Yes, sir. Directly we can get, sir. I'm saying
Yeah.
you should explain fully. No, that's why I'm saying.
Okay.
So second part I'm not getting, sir. What is the meaning, sir? If a device means, what is the property of that device, sir?
Which device? If there is a device which can change the tension in the wire at will, how will the time period change if the tension in the wire is increased?
Sir, means what is property means what? Sir, means
If
what
there
is the
is a device
property
which
of
can change the
device?
tension in the wire at will, okay. Suppose that even if tension changes at will means it can take any value. Okay. Suppose for a minute that tension can automatically change. There is some device which can automatically change the tension and it can take any value. So it can take a bigger value, smaller value, any value. But then also at any instant, the net force will be minus 2t x by ml, right?
Yes, sir.
The only difference will be that this t value, if it is bigger, then this term will be bigger, right? But it will represent SHM because anyway it is proportional to x. Acceleration is proportional to x.
Yes, sir. It's proportional to x at any.
At any instant, if we see, it is proportional to x. And if suppose this value is increased, then omega will increase. If tension is increased, then omega will increase. Omega will increase, then time period will decrease. This is how the time period will change if the tension in the wire is increased. If the tension in wire is increased, time period will decrease. Here also you
Yes,
should
sir.
understand
Understood.
that that's it.
So means that the device does not show any effect on the equations of motion. So
Just
without giving,
imaginary, known device also that it is simply you have to assume that tension can take any value. there is some device, nothing else.
Yes, sir. Okay, sir.
Okay, now try this one. This is the last question. After that, we'll discuss some concepts.
A particle of mass
Do
is
it
just
fast.
like a particle in there, a particle of suspended suspended the alpha was then strength of force constant, force constant. The string pull this at as a string go, it is spring. In which a combination of strings. The maximum value of x. Okay. So that is the motion of a simple harmonic. The maximum value. Find the maximum tension in the string if x equals to energy by 2q.